morning, learners. My name is Mr. Poch Lola once again, representing Black Slides Online Tuition Providers. Remember that in this series of online lessons, you can also access such subjects as chemistry, biology, and mathematics. But for the time being, physics is being offered to you for free, regardless of which school you are attending. But if you need extra subjects such as chemistry, biology, and mathematics, you are welcome. All you have to do is send us a text message on the number shown on the screen here so that you can enroll. In any of these subjects. So send us an inquiry to find out how you can do that. On a special note, let me congratulate the Form 2s, rather the Form 2s who are going in Form 3 now. They have qualified for entry into Form 3. Congratulations are in order on you. Welcome to the senior level of learning. Now you have transitioned, you have moved from a junior level. Now you belong to a senior level, which is Form 3 and Form 4. So welcome. I have an offer to make to you if you are in Form 3 that you can enroll in the sciences, these sciences, chemistry, biology, mathematics. I'm also offering an introductory course in all these subjects to all those who have just passed their JC exams. Regardless of which school you are going, I'm going to introduce you to Physics Form 3, the very first topic of Form 3 Physics, for free. But if you want, you can also enroll in introductory courses in chemistry, in biology, as well as in mathematics. Alright, so thank you very much. Once again, my name is Mr. Poch Lola, representing Black Slides Online Tuition Providers. Please take note of our contacts down here, the phone number which you can access us on. You can reach us on, whether by WhatsApp or by calling. In today's lesson, this is a physics lesson. Welcome to physics lesson, topic number 12. Topic number 12 of your Form 3 physics. This is a continuation of a topic called resistance, electrical resistance. We have looked so far at definitions of what resistance is with examples and with theories and all that has to do with it. We've looked at resistors, the materials that oppose current and their types, such as fixed resistors and variable resistors. These are types of resistors which are in common use. We also looked at, in our previous lesson, color codes. How you can use color codes to calculate the resistance of a resistor. Today we continue looking at a subtopic which is an extension of color codes, and this is standard notation for resistor values. Standard notation for resistor values. Standard notation. Alright. What is notation? You have seen notation before, like scientific notation of numbers. Notation, alright? Standard. What is standard? Some standard notation is just a way of writing values. Put simply, alright? When we put it in a simple way, standard notation is just a way of writing values of resistance, alright, which we have agreed worldwide. Standard. Standard means something that is accepted everywhere, right? So standard notation for resistor values is just a way of representing values of resistors, and that's what we are going to discuss today in this lesson. Alright, so standard notation of resistors is just a shorthand. It's a shorthand. It's a shorthand way of representing the resistance of a resistor. It's a shorthand. Shorthand is a short form of writing something, yeah? So standard notation is just a short form or short way, a shorthand way of representing the resistance of a resistor. Alright, so to do that, remember that some fixed resistors have their resistances printed on them in standard notation. In other words, in short form or shorthand. In shorthand. Shorthand means a short way of representing a value or representing a statement. So you're trying to write something in short. We call that shorthand. Okay, we call that shorthand, shorthand way. Alright, so we are saying some fixed resistors have their resistances printed on them in standard notation. Standard notation, eh? Alright, okay. So these notations are represented by letters. That's what we are saying. So we use letters to represent the notation, the standard notation of resistor values. We use letters. These letters are the letters R. Wherever the letter R appears in a value of a resistance, it means there is a decimal point there. Wherever you see an R, you see an R in a value of a resistor, it means there is a decimal point there. Let's suppose that an R appears first in a value. That means the decimal point is right there where the R is. If the R appears in the middle of other symbols, it means that the decimal point is right there where you see the R. Okay? When you see the letter K, as you learned in measurements and SI units, which is topic number 1 in Form 3, K stands for kilo, which is 1000, right? So 1000, 3 zeros. K for kilo, right? Mega is for million, or 1000,000, which is 100,000,000, 6 zeros. So if you see an M, okay, at the end of a value, it means that there is a million there. Or if you see it in the middle, it means you have a million there to be multiplied. Very important to note this. So we are saying wherever you see a decimal, right there where you see the decimal in a series of digits of a value of a resistance, that means you have to put a decimal point there. K stands for 1000. K stands for 1000. All right, or 10 to the power 3. Remember, this is called a kilo. It's called a kilo. And then you have a mega. Mega is 1 million. Mega is 1 million. 10 to the power 6, right? 10 to the power 6 is called mega. All right, so let's look at some instances where this is these notations are used in representing the resistances of fixed resistors. So the table to your right, we have a table to the right, this one here. The table to the right shows some standard notations and what they mean. I want to take you through one by one, each one of them at a time. All right, let's look at R27. What is the meaning of R27? Suppose you have seen a resistor that is marked R27. What does it mean? So I said wherever you see the letter R there, it means there is a decimal point. So this R alone means 0 point. Okay, this R means 0 point. And then you have 27. So R27 means 0.27 ohms. I hope you get that. Wherever an R appears, it means a decimal point is right there. So R27 means 0.27 ohms. 0 point, this one, R. While 2R7, it means the decimal point is between 2 and 7. So you have 2R7, the decimal point lies between 2 and 7. So R2R7 means 2.7 ohms. Don't forget the unit of resistance. The unit of resistance is the ohm. All right, let's look at the meaning of a kilo. K. K. What does K mean? All right, so we have 3K0. What does it mean? 3K, the K is lying between 3 and 0. You know what that means? Okay, it means you should place a decimal point. Here you place a decimal point between 3 and 0, so that we have 3.0. all right, can you write that aside? Write it somewhere. 3.0. Then multiply that 3.0 by 1000. 1000. All right, I hope you get that. So 3.0, because the K is lying between 3 and 0, that means there is a point here. So multiply that 3.0 by 1000. If you do that on your calculator, you should be able to find 3000. Take 3.0, then multiplied by 1000. It will give you 3000. If we shifted the 0 at the end of, the point, the K, if we shifted the K to the end of the 0 there, it means it would be 30 multiplied by 1000, which would be 30,000. But here we are saying 3.0 because the K is in the middle between 3 and 0. So write 3.0, then you multiply by 1000. It should be capable of giving you 3000 ohms. Alright, so look at 5K6. What does it mean? 5K6. Remember, a K is a kilo. All right, so here it means that since it is in the middle, the letter K is in the middle between 5 and 6. So you write 5.6 first, then multiply that 5.6 by 1000, because K means 1000. So when you multiply 5.6 by 1000, you will get 5,600 ohms. Please verify these values from your calculator. Show on your calculator that you are obtaining these values. All right, what about 47K? Can you figure out what 47K would stand for? What would be 47K? 47K. All right, 47K, remember, K means kilo. All right, so all you have to do is, there are two ways to do this. All right, you can either say 47 kilo ohms. All right, just leave the K there, but also you can change the K to its actual value. K is 1000, so where you have what K, the letter K, simply write 47,000. 47,000. 47,000. This is 47,000. All right, that's a 47 times 1000. All right, let's come to this last one here. 2m2. 2m2. You know what this means? It means since m is between the two twos, m, so in this case you are going to have a point again. You are going to have a point between the twos, so it will be 2.2, but don't forget to multiply by 1 million. All right, you can opt to leave it as 2.2 mega ohms. All right, so all you have to do is to shift the mega there, place it at the end of the digits. All right, so you have 2.2 mega ohms. 2.2 mega ohms. All right, 2.2 mega ohms. Okay, so in this case, 2m2 means 2.2 mega ohms. When a symbol, a letter is between numbers, that means where the symbol is, there's a decimal there. Don't forget that. Of course, we have exceptional cases with the position of an R. An R, wherever it appears, it means there is a decimal point there. Okay, that's good. That's really good. I hope you have captured this. Please, if you're not sure, why not just text me or send me a voice note concerning your issue. I'll be able to attend to you. Let's appreciate this in an example. All right. Here, you are asked to determine the resistance in ohms. Okay, shown on a resistor below. This is supposed to read as shown. This is shown. Okay, that's shown, as in shown. So this is supposed to be shown. Please correct that one. Of course, your PDF notes will show the any there. All right. So we are saying determine the resistance in ohms shown on the resistor below. So here you have a resistor. What do you think would be the value of this resistor in ohms? So this is a shorthand way. Instead of writing a number that would have appeared to be long when written down here, when printed there, we just use symbols. So 5K2, what do you think this means? 5K2, what is this? Can you figure out this from what we explained before? All right. Can you figure out this one? Okay. All right. What do you think this is? So remember that when the letter is between numbers, where the letter is, there's a decimal point. All right. 5K2 means 5.2. But since we know what the meaning of the letter K, then we multiply that 5.2 by the numerical value of k. Alright, so what is the numerical value of k? It's 1000. 1000, yeah? So 5k2 means 5.2k. If you shift the k to the end, it will be 5.2k. Alright, but then the k here is doing some work there. We need to change that to its numerical value. So the numerical value of k is 1000. So you multiply the 5.2 by 1000. It will give you 5200. Therefore, the resistance in ohms of this particular resistor here is going to be 5200 ohms. How does this make you feel? This should be an easy example to follow. This should be very straightforward to follow. So once again, the letter, where the letter is, like here you have it in the middle, 5.2. If this letter was at the end, there would be no need to put point. It would simply require you to multiply 52 by 1000. I hope you get that. I hope you get that. All right. So that's what we have. That's what we have there. That's what we have. Okay. Again, verify that you are sure about this, and you have got it right. Sometimes, apart from the notation we are talking about, apart from those letters that we have looked at, the symbols, you can have a letter which is placed at the end, very end, that is to the far right, That letter, if it appears in addition to another letter already appearing there, that means it has a meaning also. Its meaning is what we call tolerance value. The tolerance value. So the letter at the far end, in this case at the far right of a symbol. Remember that you will read your value from left to right. So let's suppose there are two letters appearing. The letter that appears at the end is also a meaningful to you as a physics student. All right? So any of the following letters can appear at the end. Of a resistor value. This should read at the end, not at the edge, no. So put end here, put at the end of a resistor value. Alright, so we have a resistor value written only printed on a resistor, and you find there is a letter at the end in addition to another letter which has already appeared before that letter. That letter represents a tolerance value. So such letters could be any of these. You have an F, a G, a J, a K, and an M. Careful there. F, G, J, K, M. When any of these symbols appears at the end of a resistor value, watch out. It means you have to include a tolerance value in your resistance. So these letters represent tolerance when they appear at the end of a given value. For example, if the letter F appears at the end of the resistance value, you have to add or subtract you have to add plus or minus 1%. Alright? If it is the letter G appearing at the end, then it shall be plus or minus 2%. And so on. So the letter J means add plus or minus 5%. Where okay, add you add plus or minus 10%, and M you add plus or minus 20%, as I'm about to show you now in an example how this could be done. Alright, so here you are asked to determine the resistance in ohms on each of the following resistors. So you are given resistors. We are given resistors, these three resistors, for us to figure out the resistance in ohms. So here we are given 7R2. Remember that where the letter R appears, that's where you place a decimal point. That means over here we have 7.2. So we have 7.2 ohms. But in addition to an R, there is the letter M at the end. This M here represents tolerance value. Remember, we said that M is 20%. 20%. So you add 20%. This is a fully represented resistance value in ohms. All right. So where the letter R is appears, it is 7.2. This is point. Then you indicate the tolerance value like that. This should be very easy thing to perform. Similarly, here we have the letter R again. The letter R, whenever it appears at the end, it means 0 point. It means 0 point, all right? 0 point. So we have 0.54. Then you have the letter J at the end. Remember, the letter at the end is depicting the tolerance value. The tolerance value. So this resistance will be 0.54 ohms plus or minus 5%, because J represents a tolerance of 5%. All right. Now, what about 8 km? 8 km. Remember, K means 1000. All right. So we have 8K. That means 8 times 1000. All right. Like this. So you have 8000 ohms. But the letter M at the end represents a tolerance value. In this case, the tolerance value is going to be plus or minus 20%. So this is how these things are done. I'm sure you're finding this very easy to follow and very easy to do. All right. But in case you are not certain about what we are talking about, just go back to the number and send me a text message explaining your concern. Your concern. That's great. Okay. Let's look at another example or set of examples. Determine the resistance in ohms of each of the following resistors. All right. So we are given resistors. These three resistors. Look at them. So we have 5K2J. What do you think this is? Can you quickly figure out this? I'm giving you 30 seconds to think about it. Okay, so what does it mean? 5kj. When a letter is found between two numbers, that means there's a point there between those two numbers, right? But don't forget what the letter stands for here. The K stands for 1000. 1000, right? So we have 5.2 times 1000. But don't forget to add the tolerance there at the end. So in this case, we have 5.2 times 1000, which is K, plus or minus 5% tolerance. In the same way, the letter appearing between 9 and 5 is K. Alright? But where the letter is appearing, because it's appearing in the middle, it means there's a point there again. So this is going to be 9.5 times 1000. Alright? And don't forget to add the tolerance. F stands for a tolerance of plus or minus 1%. Okay? 8M25. What does this mean again? 8M25. It means there's a point between 8 and 2. So that we shall write this as 8.25. But what is M? M is mega. Mega. So don't forget to multiply by 1 million. At the end, add a plus or minus 2%, which is the tolerance value. All right, I'm sure you have captured these things. You can watch the video a number of times until you are very, very sure about what is going on. All right, so for the time being, before I go, you have this task to perform. This is your work to do it. So you're going to determine the resistance in ohms of each of the resistors shown below. So you have R27M, 9km, 32RJ, 76mm, 500 kF, and 10 kg. Alright, so I want you to write down the values of these resistors. Thank you very much for your attention. It has been me once again. My name is Mr. Pochilola, representing Black Slides. Let me repeat that Form 3s, the Form 2s who have just passed their JC exams, congratulations are in order to you. You are welcome to these lessons. I have a special offer for you, which is free physics lessons, which is going to be your own introductory class. So invite your friends, regardless of which school you are attending. You are welcome. But in addition to physics, you can also enroll for chemistry, biology, and the mathematics. I wish you all the best as you progress with your schooling and the education. Welcome. Bye-bye for now.